Welcome to this explainer. Okay, so if you're a developer, or honestly, anyone who works with complex systems, you already know the ultimate dream, right? Doing way more with way less. There's this universal, almost magnetic pull in the programming world to just write less code. I mean, why type out 10 lines when you can write one, and then spend all that saved time feeling pretty smug about it? To refactor, to compress, to take a massive, bulky block of logic and magically shrink it down into this sleek, elegant one-liner, well, it feels like a superpower. But today, we're digging into a fascinating piece of source material that asks us to just pause for a second and reconsider that instinct. We're going to explore the hidden costs of our absolute obsession with concise code. Okay, let's dive into this. Is shorter code always better code? It's kind of the golden rule we're all taught from day one. The fewer lines you write, the fewer places bugs can hide. Shorter code is supposed to be cleaner, it's supposed to be more professional, and infinitely more elegant. But as we unpack our source material today, we're going to see that this assumption actually creates a huge core tension. It's a total tug of war between making the computer's job easier and making the human developer's job much, much harder. Section 1. The refactoring dilemma. To really get this tension, we're looking at a very specific real-world dilemma from developer Ang's blog post, Notes-on-Haskell-Programming. Ang was grappling with something known as point-free style. Now, in short, this is a functional programming paradigm where function definitions completely skip explicitly identifying the arguments they operate on. It's literally like giving instructions to a chef without ever mentioning the ingredients. You just link the cooking techniques together. It is mathematically beautiful, it totally removes clutter, and it is highly, highly encouraged in functional languages like Haskell. But as Ang discovered, during just a routine refactoring session, that beauty definitely comes with a price tag. Section 2. Analyzing the code diff. Now, what's really interesting about this is how radically the code transforms. Think of this code diff as the main protagonist of our explainer today. We're going to do a quick forensic deconstruction here. In the before state, we've got eTemplate pointing to getTemplate, followed by a case eTemplate of block. It takes up a few lines, right? It explicitly grabs a template and then uses a case statement to pattern match and figure out exactly what to do next based on whether it succeeded or failed. But then, look at the after state. mplain completely gutted that bulky pattern matching. It's been replaced by a single, highly concise one-liner. getTemplate, the bind operator, either, pure.left, f. The boilerplate, it is completely gone. So how exactly did Ang achieve this massive compression? Well, by using two very specific elements native to Haskell. First, the bind operator. That's those greater than and equal signs, which essentially pipe data along. And second, the either function, which is a built-in way to handle successes and failures. By utilizing these two tools, Ang successfully wiped out all that boilerplate code associated with handling the results. And here is the absolutely crucial context. This new one-liner adheres perfectly to the idiomatic Haskell approach. It is quite literally the exact kind of code a textbook would tell you to write. But while it totally solved the problem of verbosity, Ang quickly realized it introduced a brand new complication. Section 3. The readability tax. Let's move to and see how this builds a case against cleverness. We really need to build some empathy here for the future developers inheriting this code. Or hey, even for Ang 6 months down the line on a Friday afternoon. This quote from the source material captures the downside perfectly. Ang writes that this is a case of refactoring that is mentally taxing for other to read at a glance, especially if you're still unfamiliar with Haskell's point-free style. I really want to emphasize that phrase, mentally taxing. When a developer hits that sleek one-liner, they can't just scan it like a normal sentence. They have to physically stop. They have to mentally unpack the whole thing. They have to remember exactly how the either function works and how that bind operator shifts the data around. The cognitive load required just to understand a super basic data fetch has absolutely skyrocketed, simply because the code was made shorter. Now contrast that mental tax with the old, bulky code we just talked about. Yeah, sure, it took up way more space. Yes, it was full of boilerplate, but it possessed one massive, undeniable advantage. Explicit is obvious. In the original code, you didn't need to stop and rack your brain remembering how complex operators worked. It was explicitly obvious how the result, and especially how an error, was being handled by that case statement. You could look at it at a passing glance and instantly, intuitively know what the program was doing. This new code, it just hides all that vital logic behind abstractions. Section 4. The debugging trade-off. And this brilliantly illustrates the practical fallout of all this. This brings us to a highly, highly practical point of friction. what actually happens when the code breaks, because, it always breaks. When you compress your logic into a dense point-free style, you actually lose something physical. Eng points out a final really crucial realization here. The verbose before code is significantly more debugger-friendly. Why? Because when you have explicitly written out the steps on totally separate lines, you have the physical space to easily insert a trace or a log statement right between those lines if you need to debug the program. If something goes wrong in that tight idiomatic one-liner, you can't just easily drop a print statement in the middle of it to see what's happening. Actually, you'd likely have to temporarily rewrite the code all the way back into the verbose style just to debug it in the first place. So the crucial point is that we're looking at a massive pendulum swing of trade-offs here. Think about it. If we look at the verbose code, is it idiomatic? No, definitely not. But its readability at a glance is super high, and it is incredibly debugger-friendly. Now, on the flip side, the point-free code is perfectly idiomatic. It follows all the language's best practices to a T. And yet its readability drops to low, and its debugger friendliness becomes a very firm no. The big takeaway, idiomatic does not automatically equal better when you actually factor in the human element of software engineering. Which brings us to our final thought for this explainer. We've seen how removing boilerplate and adhering to the absolute strictest stylistic paradigms can actually increase cognitive load and make debugging a total nightmare for everyone involved. So I'm going to leave you with this provocative question to ponder in your own work. When does writing cleaner code actually make your software worse? It's a question that challenges our most basic assumptions about programming, and honestly, it's one absolutely worth asking the next time you're tempted to turn 5 perfectly clear lines of code into one clever little one-liner. Thanks for joining me for this explainer, and keep questioning the code.